Many years ago, I discovered the concept of what a trillion was. It had all stemmed from a math problem that I was fascinated with called Ramsey theory. I was looking for a graph, we called it R55, that had a certain property. And the property was that you had 40, anywhere between 43 to 49 vertices. And you had two different colors for the edges, right? It was a complete graph on 43 or 49 vertices, and you had two different colors. And you wanted to prove that it would force a complete subgraph of 5 vertices of either color. Now, the number of graphs on 43 vertices is huge, right? You got 43, choose 2 different edges, basically 43 times 42 divided by 2, right? Every 43 vertices could connect to any of the other 42 vertices, and then divide by 2 because you're double counting every edge. And then every one of those could have 2 different colors. So it's the number of total graphs you could potentially, the number of total colorings you could potentially have on those 2 colors. If we pull out the scientific calculator, 2 to the power of 903. That's more than the number of atoms in the universe. Fortunately, you don't have to list out all of those graphs because there are some heuristics you can use. For one thing, once you've already colored something like this, you backtrack, right? You don't go on to color the rest of the vertices, right? There's other heuristics you can do that are based on combinatorial counting and all that. Eventually, I wrote a program that did branch and bound, right? It would start searching. For one thing, the order of the edges you choose actually matters. You can choose the order of the edges in a way that you force these things to show up early, so you prune early. And then I wrote a program that added in a bunch of other counting heuristics. And I wanted to see how long that program would take to run. I knew I wasn't going to run it. I wasn't going to start the program and wake up tomorrow and see the answer. I wasn't stupid to think I could do that. But I ran what I estimated to be 1/1000th of the program because some of the branches you could see that, okay, it went one way or the other, so you could divide the program into half and then half again. And you do that 15 times, you get roughly 1/1000th, right? 2 to the 15 is roughly a billion. Is that right? 2 to the 30. I'm sorry. 2 to the 30 is roughly 1 billion. So I ran what I estimated to be 1/1000th of the program, and it took about 1,000 seconds to run, right? And so I thought, hey, that's not bad. So 1,000 times 1 billion, the whole program would take 1 trillion seconds to run. And I thought 1 trillion seconds was a few years. I thought before I left the PhD program, I just need to find somewhere to keep my computer safe for a few years. I thought I could handle that. Actually, I have found that keeping a computer program running for more than a few days is a lot more challenging than you would expect. Especially with Windows, it likes to reset on you. So you actually have to periodically write something to the disk and then reload it, or do something clever, right? I found ways to hack around Windows trying to update, but it has also backfired. A lot of times things get so out of date that various programs aren't going to run anymore. And I've discovered there's a lot more to it than just, I'm going to keep my computer on for 2 years. That doesn't really work very well. Just my own observation. Okay, so trillion seconds, I was thinking on the order of 2, 3, 4 years, right, before I finish my PhD program. I get out the calculator, and I say, hopefully I get the number of zeros right, 1 trillion seconds. Let's see how many minutes that is. You divide by 60. It's that many minutes. Let's see how many hours that is. That doesn't look too bad, right? You got 24 hours in the day divided by 365.25 for the number of years, and we get 31,688 years. Now, I was working out of a small office. I want to say, I think I have recorded a couple videos in that office, actually. Let me see if I can draw the layout of the office. We had this hallway, and there was this kitchen. Here, it was really nice. I could put my crock pot in there to cook stuff. And then there's this door, and then I used to love to collect pennies made before 1982, which were solid copper, and I placed that tub down here, if I remember correctly, and the desks were over here. My computer was here. It was running that trillion-second program. I would sleep underneath the desk down here. I had lost my apartment because of a relationship problem, and I lived out of there for almost as long as we've been quarantined now, if you can believe that. So it was like my practice quarantine, even though it was 10 years, 10 years too early, right? Anyway, I fantasized about the whole building. This was on the 3rd floor, if I remember correctly, of a building that was, I want to say a mid-sized building. And I fantasized about 30,000 years later, the whole building was covered with snow and ice. We were in the next ice age. The computer was still sitting there, and maybe I was mummified in there because I was never going to move out of that office. And the computer was still working on R55. And it just really highlighted just how big a trillion is, right? Even though seconds pass so fast, right? Imagine trying to go on an intermittent fast lasting 1 trillion seconds.